evening, our special guest speaker, Michael Carroll, is an author and artist who received the AAS Division of Planetary Sciences Jonathan Eberhard Award for the Best Planetary Science Feature Article of 2012. He lectures extensively in concert with his various books, some of which are for sale here tonight. And he has done invited talks at science museums, aerospace facilities, and NASA centers. He's a fellow with the International Association of Astronomical Arts. His 30-some book titles also include Alien Volcanoes, Space Art, Drifting on Alien Winds, which I own, and several novels. His latest book, which is part of Springer's science and fiction series, is the novel Lords of the Ice Moons, which takes place primarily on Enceladus. One of his paintings is on the surface of Mars in digital form, above the Phoenix lander. Carroll is the 2006 recipient of the Lucien Rudeau Award for Lifetime Achievement in the Astronomical Arts. And I want to tell you that his art is not pure fantasy. Everything that Michael creates is based on real data from real missions that comes back from the various sources. And when you look at his work, you're not looking at just something that came out of his mind, but something that he sees as a very realistic creation or a very realistic approximation of what we're going to find when mankind finally gets to these locations. Now, there's a story he may want to share with you about how people in his association are required to be attracted to orange food. He in particular loves orange marshmallow circus peanuts, a candy that has undoubtedly been outlawed by nutrition boards of several countries. But that story is his. Thank you.
Well, good evening. It's great to be back here again. It's always fun to be with this group. You guys are welcoming. You know your stuff. That part is intimidating for me because I know you're going to ask hard questions. But I'll just make up the answers. So, thanks to the DAS once again. Ice worlds in the outer solar system are fascinating for many reasons. But before I get into the details, people have asked me about the book cover of this most recent book. It has some pointy things sticking up. Here, let me just get one since it went away. It's got these penitentes, in effect, sticking up, but they're far below the resolution that we have of Europa. We don't have that detailed imagery of the surface. So how do we know that those are there? The most detailed images we have of Europa are equivalent to what you would see with the naked eye at about 10,000 feet, okay? And the most detailed mosaic was taken right here in that little spot, and I'm going to show it to you. Now, what's fun about this is that NASA has only released a little bitty portion of this, so what you're seeing tonight is something that you probably haven't seen, at least not very often. These ridges are all about the size of the foothills out here, and as we go down further and further, the resolution is getting better and better and better. Remember, you're seeing ice. There's no rock here. This is pure ice. And as we get down to the bottom, we see even more detail until Now this is actually not quite to scale, but if I took this building and put it to scale on this image, it would be about that big. And that's pretty impressive when you think about the fact that the Galileo spacecraft was traveling about 6 times the speed of a rifle bullet, as it zoomed past this moon and took these detailed images. So this is Europa from a little bit further away. How can we possibly tell that it's got those little pointy things? Well, the way we do it is with radar. And when we bounce radar off of Europa, it turns out that there's this bumbly stuff that comes back in the radar signature, and it's probably very similar to what people call penitentes in the Atacama Desert. Here they are. And so these may well be glimpses of what Europa is like at the equator. This is not good news for landing something, but it's pretty. And it may be, in fact, that these ice worlds have lovely canyons and even caves like this one. This is a cave that I saw in Antarctica. It felt like being on the set of Frozen. And so you can let your mind wander a little bit and just imagine the possibilities out in these wondrous places. Or not. Before we go, most of the ice worlds that we'll be talking about tonight are moons, okay? And so before we go into detail, let's just take stock of the fact that the numbers of moons have gone up dramatically in just the last couple of years. Actually, they were probably already there, but our knowledge of them has. Saturn still comes in as the king of moons at 82. This number is up because people have been studying the Cassini data and have discovered and confirmed more moons out there, which is pretty cool. Even Neptune at 14, that's not bad, right? When you consider Earth has one, oh, what? We need to catch up. So before we go to the Galilean satellite, Europa, and the others, let's take a look at something in between. Beyond Mars, but before Jupiter, lie the asteroids. And some of them are a little bit wet. A little cool. What is the largest asteroid? Ceres. Beautiful. See, I knew you guys could do this. Very good. So here's Ceres compared to the Earth and the Moon to scale. And it turns out that Ceres, unlike Vesta, which also was recently visited by the Dawn spacecraft, is a very wet place. It has probably a subsurface ocean, probably not global, not completely all the way around, but certainly inventories of water underneath, most of which are frozen, but not all of them, because look at that white stuff. That's not ice, it's salt. Salt has come out from the inside, and the easiest way to make that happen is to have briny water that escapes into the vacuum of space, and what's left is essentially table salt. But there are other evidences of weird things going on there. This is Ahuna Mons. Ahuna Matara. No, that's not it. Very, very strange mountain. This is a cryovolcano, a super cold volcano. It's an uplift that is probably created by multiple eruptions. And so it turns out that Ceres is covered with very, very ancient terrain that appears to be sunken volcanic structures. So, so there is some very active geology going on at Ceres. Now we go back to Jupiter and the 4 big moons. These are not to scale, by the way. Io is the one on the far right, that way, yes. And it's the only one that's not an ice world, okay? It is rocky. Beautiful little volcanic moon. All the volatiles are long gone. It is erupting sulfur dioxide, and it has some classic volcanism, silicate-based stuff too. But these other 3 are ice worlds, and the one on the far right is beautiful, and the one in the middle is yes, and then the one on the left is all right, so Europa is about the size of the Earth's moon. It's little. Ganymede is the biggest moon in the solar system. It's a little bit bigger than the planet Mercury. So these are worlds in and of themselves, and they have the complexity of worlds. These are three views from the surfaces of these moons looking out at Jupiter. You have Europa over there, Ganymede in the middle, Callisto closest to me, and I'm going to draw you a little circle in the sky on Europa so you can see how big a full moon in Earth's sky would be, okay? So Jupiter would be pretty darn dramatic, right? I mean, just imagine looking out in the night sky and seeing Jupiter that size. Very fun. Our view of the Galileans has changed over time. Lucien Moudon, who was the director of the Moudon Observatory in Paris, France, at the turn of the last century, was also an oil painter, and he painted what he saw through the lens. He was a very, very good observer, and this is a painting he did of Jupiter seen from one of the Galilean satellites. Just to its right was, this was a view of Europa done in 1948. It's prescient because you know how many palm trees we have found on Europa. How did they know? And then this is a painting by David A. Hardy, done before the Voyager encounters, and then Marilyn Flynn did the painting at the lower right, with all the good data that we got back from Galileo. It also reflects some new information that indicates active volcanism in the southern hemisphere of Europa. That's still a bit controversial, but they're doing work on that. We are not sure what the guts of Europa look like, except that it has a very, very deep, briny ocean, a saltwater ocean. It may have a thin crust, it may have a thick crust, just like Pizza Hut. However, it does look now like the crust is thicker, like this one, and it has diapirs moving through it. A diapir is simply a warmer part of a solid layer. So there are these warmer bits of ice migrating up and breaking the surface. And both of these models explain what we see on the surface. So it's a little hard to tell what's going on. The exciting thing, of course, is that in either model, we have active volcanism on the ocean floor. And wherever we have that on Earth, we have rich life, even though it's cut off from the sun completely. On Europa, it will be cut off from the radiation of Jupiter, which is a good thing. And so it may be that there is a chance that there is active biology going on at the bottom of the sea on Europa. Here is the Hubble data, this highly detailed image right here, overlain with the Galileo picture. That is hydrogen. And when you see hydrogen floating around, it's likely that it used to be water, at least in a context like this, because water dissociates, it gets torn apart in sunlight, and so the oxygen goes away, the hydrogen is left, and we have seen this event now multiple times. Hubble saw it twice, but then they went back into some older data, couldn't find it, it looked like it was erratic and not real, but now we have confirmation. So very exciting stuff going on Europa that's a little bit like Saturn's moon Enceladus. Why is Europa like this? It should be frozen solid. It should be this ball of boring ice. But no, there's something going on. What could it be? Well, it turns out that on one side, the gravity of Jupiter and Io are tugging on this little moon, and the gravity of mighty Ganymede and a little bit Callisto are reaching out and grabbing it on the other side. And so what happens is a kind of cosmic taffy pull. It pushes and pulls this little moon until the inside of it gets heated up. There's heat generated from this. It's called tidal friction, and it's very important in the outer solar system. We will see it as a moving force throughout the outer solar system, especially moons. It's a very, very important thing to understand, and we're just beginning to understand its nuances. Now we're out at Ganymede, a very cool place. This image by Ted Strike, using Voyager data, actually. And this is part of the surface. Now, remember, again, we're looking at ice, okay? There are some impurities, but this is pure ice. The rock on these moons is way, way down at the core, okay? So, true ice worlds on the outside. What we're looking at, imagine that you take books on a bookcase, and they're all straight up and down, and then you tap them, lean them over, okay, so that they're like this. That's what's happening here, okay? There are fractures in the ice. They've leaned over until you get these parallel ridges. There are probably other ways that you make parallel ridges on Ganymede. It's a very dynamic surface. These are a couple of different models of how that might happen. And there's stuff leaking out. This is very exciting to geologists. Leaky moons, that's big on their list, okay? And here it is. Something has come out from the inside. Again, it's warmed up from that tidal friction and hot ice, you know, it's probably as warm as 30 degrees, comes up and breaks out and floods the surface. Now, this is part of the Galileo mosaic that has half a dozen of these features flowing into a big plain. So we think that there are pockets of this malleable ice, but there's also an ocean very deep, deep inside. This ocean is different from Europa's. The reason is that it's locked in the ice, top and bottom, okay? It's sandwiched in, so there's a thick ice crust on top, then there's a global ocean, and then more ice down below, okay? So it's a little bit different. But if you go down to that rocky core, you may have a similar situation to Europa, in other words, active volcanism. And if that volcanism occurs at that solid ice, it's going to melt a spherical ocean. So you would have these transient places where there's liquid water surrounding these erupting mountains. Couple different ideas on what Ganymede looks like on the inside. This is the classic model we just talked about, but it turns out that when you pressurize ice, its nature changes, its behavior changes. And so it's possible that as that ice transitions from one phase to another, you have sandwiches of liquid in between, like this. So Ganymede may be much more like an onion than the classic model would indicate. And here's something else that's fun. If you go up to where it says ice 3, we'll zoom in there. Because of the way the water is pressurized and the ice pressure changes, on that one layer you would get snow going up. It snows the opposite direction. So, this is science. All right, now at Callisto, the furthest one out, talk about penitentes. This has these beautiful pointy things that are leftovers from these craters. It looks like something's been chewing up these craters and leaving these pointy ice protrusions. They're about the size of the buttes in Monument Valley, or Arches National Monument. Okay, that's the scale we're looking at there. And again, there is a global ocean, but it would be a very desolate place, locked top and bottom in ice. I suppose you could send a probe and it would see something like this, but it would be a lonely, lonely place. No dolphins. It does turn out that we are discovering ice worlds, ocean worlds, throughout the entire solar system. This is something that was off our radar screen just a decade ago, completely. We knew that there was an ocean on Europa, and there were some guesses about other moons, but it turns out that there are probably a lot of them. Look at all these moons, all these different worlds, ice worlds, that have oceans underneath. So it's really a new chapter in planetary science. Most of these ice worlds are very dormant or dead, big cratered balls of ice on the outside. Even the ones that have oceans, if those oceans are really buried, they're going to look like these guys. This, of course, is Darth Vader's favorite moon. But when Voyager went out to Saturn, it saw some stuff that was very exciting and hinted at what's really going on. This was one of the best images we had of Enceladus. And you can see right next door was that moon that I just pointed to, Mimas, okay? Mimas and Enceladus orbit very close to each other, okay? Enceladus is just a little further out, but look how different are all the craters. Something has flooded across that whole region, wiping out lots and lots of the ancient crater terrain. Voyager could not answer that question for us, okay? We did know, however, that Enceladus was embedded in the E-ring, which is a big, amorphous, fluffy ring of Saturn. And so the thinking was that maybe there's something going on there, but there was no confirmation until we got out there with Cassini. And then we saw these beautiful blue canyons. Anybody know what they're called? Tigers, stripes, very good. All those things are parallel canyons centered on the South Pole, and they are where these spectacular geysers squirt 400 kilometers into the sky. There's no air on Enceladus to slow them down, so they go out and they make the E-ring. They are creating the E-ring around Saturn. So, cryovolcanism at its best. Why is Enceladus like an orange creamsicle? Well, it's of course because, and I know you were asking that, because it has a frozen crust on the outside, but it's warm and chewy on the inside. And we know why that is, right? It's that tidal friction once again. With Enceladus, it's a little bit mysterious though, because the numbers don't quite add up. It's getting some tidal friction, but its orbit is regular enough that it shouldn't be getting enough to make happen what's happening. So that's something that they're still, dynamicists are still studying. Very interesting. Here we are flying through those geysers. The sunlight is peeling through these sheets of material from the other side. Let's see that again, shall we? Here we go. So Cassini was at about, I think it was at 56 kilometers at the closest to this pass. And this stuff looks very dramatic, squirting out all over the place, but if you stood right next to it and held your hand in it, you wouldn't feel it. It's very, very fine stuff, okay? Curtains of this stuff just migrating way up hundreds of kilometers into the sky. And here is an elegant view of Enceladus embedded within the E-ring of Saturn. Very pretty. If we had really been paying attention back at Voyager, we would have known. Because, look at this, here is an image that Voyager took kind of over the shoulder as it was leaving the Saturn system. This is Voyager 2. And if you look carefully up there, it just happened to capture Enceladus in the corner of the frame, and there it is. Highly pixelated, but next to it is a Cassini image that I've oriented to show you what's probably happening in those pixels. Kind of fun. Little history. So, to figure out what Enceladus really looks like in detail, I went with Rosalie Lopez, who's a NASA volcanologist, down to Antarctica. At least it was a great excuse to go to Antarctica. So here's McMurdo. The reason we went was because the southernmost active volcano on Earth is in Antarctica, Mount Erebus, and it has ports, fumaroles on the side that build towers of ice. We think that those towers may have some analogies, some analogs in the outer solar system, and specifically in places with cryovolcanism. So up on Mount Erebus, it's essentially a 14er. You have to sleep in tents. It's lovely. There's no hotel. There is a thing called the Lower Erebus Hut, and it's a little wooden structure that's heated, which is great, but it's only for scientists who've been working out in the field to come in and get warm for a while. There's no room to sleep unless it's a disastrous blizzard or something. They've had a few of those where people had to retreat into the hut. But most of the time you spend in these tents or out in the field, and this is one of those strange, lovely formations that grow. Some of these are 60 feet tall. They're just spectacular. This was taken with Rosalie's iPhone. Very nice shot. At the time, my SLR had frozen stiff. Battery was dead, so we had to rely on the little iPhone, which did just great. So this is my impression of what some of those formations might look like if they are on Enceladus. You can see the most detailed image we have of Enceladus on the left there. And those blobs are possibly boulders, the size of a house roughly, but they may actually be these towers as well. And some work is being done at JPL right now to see what the vertical aspect of these is. We don't know yet. Jury is still out. And now, one of my favorites, Titan, the moon with more atmosphere than an Italian restaurant. In fact, let's see how much it has. If we look at the solid surfaces around the solar system, here's a few of them. Earth's moon, you can see there's just nothing to breathe. It's a nice, hard vacuum. Europa has a little bit of stuff, some atomic oxygen and other things floating around. But when you get to Mars, you're starting to have an actual atmosphere. Not much. The Martian atmosphere is equivalent to the Earth's at about 100,000 feet, okay? So there's just not much there. Then you get to Earth, Venus, you know, is 89 bars. It's 90 times, the air is 90 times as thick as what it is here. So if you took a quarter out of your pocket and dropped it, it would quake like a leaf as it fell to the ground. It's like water. Titan, though, is the second densest atmosphere, 1.5 times what it is here on Earth. And with only 1/8 of a G, the average human would have enough strength to actually fly. I think we should try. All right, our changing view of Titan. This is Pioneer 10 up in the upper left. Then comes Voyager. A couple of views from Voyager, and we just couldn't make out much because its cameras were not sensitive in the region where you could see through that fog. We didn't know that at the time. Okay, we just were doing our best. So those are what we could see. Then Cassini comes along, and we see this beautiful image of the layers of atmosphere. Here we're seeing through the haze to some of these great methane seas at the north. And then finally, the European Space Agency's triumphant Huygens probe, which went all the way to the surface and sent us the first images from the surface of a moon besides our own moon. So 2 seas on Titan, and they are, where are they? Northern Hemisphere is where the methane stuff is mostly, yes. But then under the surface, under the ice, there is a global ocean. And one way that we could see, there were 2 ways we could see this. One was the magnetic fields that are generated by this moon. That's how we found those at Europa as well. The Earth has two sets of magnetic fields. One comes from the core, one comes from the ocean. They're both very different. We saw that same fingerprint at Europa, and we see it also at Titan. But we also see that the landmarks keep showing up in the wrong place in the images. If you're very, very careful, you can see that the crust is decoupled. It's floating on the ocean. So, global sea on Titan underneath. Here are a couple of those methane seas. You can see the sunlight glinting off of those in the view on the left. This is Kraken Mare, the biggest methane sea on the right. This is Ligeia Mare. They're just elegant. They're just beautiful, beautiful places. They look very much like the fjords in Scandinavia. And remember that it's raining methane there, okay? Water is equivalent to rock, okay? Water is the consistency of granite at Titan. So it doesn't rain water. Instead, it rains methane, which we essentially heat our homes with. So it's a crazy mixed up world. Here's a quick cutaway view so you can see that this interior ocean splits the ice crust so that it has wiggle room there on the surface. So Titan is a wonderful, magical place to go, and certainly is high on the list of priorities for future exploration. This is a view I did for astronomy, I think, actually. But just no one, by the way, is sure how clearly we can see Saturn from the surface. Some people think you just can't. There's too much fog. Ralph Lorenz, who was on the Huygens team, said that if you wore polarized sunglasses, he thinks you would have a pretty clear view of it. So we'll see. We'll just have to go. Here is a close-up view of Maida Insula, a big island at the edge of one of these seas. This is Kraken Mare, which is as big as the Black Sea. These are big, big things, okay? And Maida Insula there is about the size of the island of Hawaii. So, and that green X is where my first novel takes place. A couple of years. So, all these ice moons flying around make us wonder about things, especially when we look at the makeup of Saturn's rings. They're almost pure ice. There's this beautiful glistening ice going around this planet. And so how did they get there? One theory is that a Titan-sized ice moon came zooming in a little too close into what's called the Roche limit. It was torn apart by the gravitational pull of Saturn, and what was left made the rings that we see today. Now, the next stop, Uranus. We're approaching the end of our tour. Uranus has a whole bunch of kind of mid-sized moons. By the way, after Jupiter, all the moons around the giant planets, well, with mostly the exception of Neptune, are mid-sized moons. They're a different size than what you find in the rest of the solar system, okay? They're kind of in between. So here are a bunch of in-between moons. Miranda's the tiniest one, and we're going to have a look at Ariel, because she's named after a Disney thing. What's all the Disney stuff in these outer moons? I don't know. Anyway, at the south pole of Ariel, which is oriented to the top here, you have a bunch of canyons that are very typical of volcanic activity. You look closely at them and they have furrows in the center. The edges of the canyons indicate flow, not like precipitation, but rather like a drainage from something like cryovolcanism. And so if we put ourselves right there at that little green X and look toward the right, we will see Uranus. All of these moons are tidally locked. They keep one face toward the planet, okay? What that means is, if the planet is up here one day in the sky, It's going to be there all the time. It's not going to move, okay? Because wherever you go on the moon, our moon, if you can see the Earth in the sky, it's always going to be in that same place. The Earth will go through phases like the moon does, but it doesn't move in the sky. So the same thing here, we look toward Uranus, and this is roughly what we would see from, you can see the detail of the flows in the canyon, how things are hit by a few craters, but not many. So something has been going on there actively fairly recently. This is Miranda, and it's even weirder. This is a moon that is probably mixed up because of a specific event. So when a planet or a moon is forming, the heavy stuff migrates to the center, the light stuff rises to the top, okay? And that's where you get the crust. So you have the core, mantle, and crust typically. But it even happens in gas and ice giants where you get the heavy stuff going to the middle. We think, and that's called differentiation. We think that Miranda was in the process of differentiating. The heavy stuff was almost all settled down when some big space rock came in and Bruce Willis was nowhere to be seen. So it plowed in, mixed everything up, and then the moon froze before it had time to differentiate again. So we see the very, very strange formations that have some echoes of other places in the solar system, but they're really, in many ways, unique. So these are called circuses, these oval areas, and some of them have places that look like they were volcanically active. And there is the biggest cliff in the entire solar system that we know of, called Verona Rupes. Here it is sticking out of the night side, and so we're going to have a look at just how big it is. How many people here have seen the Grand Canyon? Okay, it's pretty amazing, right? It's a gravel pit compared to Verona Rupes. Let's have a look. So there's the Grand Canyon at the bottom, and we're going to take a look now at the wall of Verona Rupes. Now, how could base jumping be from there? Yeah. All right, our very last primary planet, we won't get into that discussion, is Neptune. And Neptune has a big moon, which is what? Triton. Very good. So, Triton is a bizarre and wondrous ice moon. It's a little bit smaller than our moon, so it's not real big like some of the Galileans. But here we are looking up at the South Pole. This is a projection of multiple images. And notice the dark stripes that are swirling around. Very, very mysterious when we first got there. We had no idea what those were. The landscape is tortured. It looks like someone took a blowtorch to it in some places. In the center there is a view of some terrain that we call cantaloupe terrain for obvious reasons. But what are all these stripes down here, all these dark blemishes? Well, it turns out that they are a new form of cryovolcanism. We think what's happening is called solid-state greenhouse effect. The pink ice on this world is what you're breathing most of right now. What's mostly in our atmosphere? Nitrogen, yes. Nitrogen, it's so cold out here that everything in this room would basically fall down in a bunch of ice, okay? And Voyager just happened to capture an erupting volcano, actually a couple of them, and the plume is up toward the top, so I'm going to trace it for you so you can see it. There it is. What happens is these things rise about 8 kilometers, 5 miles, up into the sky, very, very calm air, where they hit a jet stream. And then that pulls it along for hundreds and hundreds of kilometers. and it deposits this dark stuff on the surface. Now, the solid state greenhouse effect happens in the nitrogen ice because nitrogen ice is even clearer than water ice. And so we think what happens is the sunlight goes through that ice, warms it up at a deeper level, and a pocket builds of gaseous nitrogen, which eventually busts through the ice and makes this probably very short-lived volcano. So it would be a spectacular place to visit, probably not very dangerous, except if you got cold. You know, very bad thing. Yes. So Triton was full of surprises, fun place, and we knew that Pluto was about the same size. We also know something else about Triton. It didn't come from Neptune. It did not form in the Neptunian system. It probably migrated in from the Kuiper belt. The reason we know this is it's going the wrong way around the planet. If you're up above the north pole of all the planets in the solar system, they all spin counterclockwise. Everything does. The rings of Saturn, all the moons, everything tends to, with a couple exceptions, of course. So that's the direction that the cloud spun in when the planets were forming and when the sun was forming. Anything that's going clockwise against the grain probably was disturbed, came from somewhere else. Okay, I'm disturbed, but that's different. So Triton is going the wrong way around Neptune. It probably came from the Kuiper belt, which is a whole bunch of things just outside of there. It starts at about Neptune and moves out. Pluto also comes from that population, and so we thought that Pluto would be a twin of Triton. They're essentially the same size. They came from the same family, and it turns out that nothing could be farther from the truth. Pluto was a surprising, astounding place. Nothing like Triton, although both of them do have frozen nitrogen. But Pluto has other stuff, frozen carbon monoxide. It has mountains of water ice that actually float on top of plains of ice. So spectacular thing with just lots and lots of layers of haze in the atmosphere. That's another thing that we didn't expect. Part of the reason we sent New Horizons when we did, part of the rationale was that Pluto is moving away from the sun. Its atmosphere is probably going to collapse and freeze to the surface. That's what we said. So we expected when we got there to not see much. And look at all that atmosphere. There's fog. You can see beams of light at the terminator, the line between the day and night side, these shadows going through the fog. So it's a spectacular place. This is my view of what it would probably look like looking up at Charon up in the sky at sunset or sunrise. It's got a plethora of varied landscapes, including weird lakes. How do you get a lake in a vacuum? Pluto is essentially a vacuum, okay? So this is very mysterious. We've got this stuff over here that looks like sand dunes, or you can't possibly have wind, right? Part of it is sublimation, where the ice, as it melts, is turning directly into vapor. There's no pressure, so you can't melt ice like you can here. Instead, it turns directly into a vapor. And then on the far right is snakeskin terrain, one of my favorites. But this may be related, oddly, to the equatorial regions of Europa, those penitentes that we saw. This stuff may have a very similar process going on to make it happen. And then we do have cryovolcanism on Pluto. We have identified several sites, including this, which is right Mons. You can see this big region here with a collapsed pit in the top of the mountain. It's a classic volcanic form, but remember, you can't have, well, the magma that you have here is not liquid rock, it's liquid ice, okay? So lava on an ice moon is water. Charon is right next door. It's got this funny cap on the top of it. It probably has one on the bottom too. We only saw one hemisphere. And we think that this is organic material that has come from Pluto. We think that the atmosphere of Pluto is migrating to its moon Charon, and that atmosphere would be deposited on the poles in the form of hydrocarbons. So very strange. There's also Kubrick Mons, the floating mountain down there in the corner. I love that. So the nice thing to me about Pluto and Charon is that they too are tidally locked. The Earth and Moon are tidally locked, but the Earth spins around every 24 hours. It takes the Moon a month to go around. Pluto and Charon go around each other. And what this means is that you could build a space elevator. Yes. So don't laugh. This is going to happen, and if anyone approaches you about investing, this is a good one. All right. So we are finding worlds around other stars that must also be ice worlds. They're in the right places, they're the right size, but we won't be able to see them very soon, so we have to just satisfy ourselves with the wondrous menagerie of worlds that we have seen here, and someday we'll visit and work at. Thank you.